Video topic 4 Phenolic resin by Jayden. Forming phenolic resin, raw materials and inputs required. The two main materials used inside the production of phenolic resin Video topic 4 Phenolic resin by Jayden. Forming phenolic resin, raw materials and inputs required. The two main materials used inside the production of phenolic resin are phenol and formaldehyde. These two materials need to be purity of 99% of above to ensure reaction conditions and high resin quality. The ideal molar ratio of phenol to formaldehyde varies based on the needed resin type, less than 1:1 mole ratio for Novolic and more than 1:1 mole ratio for Rysol. In addition to these two materials, acid catalyst or alkaline catalyst are added to control polymerization. Other small quantities of additives can also be used, such as fillers or wetting agents, to ensure the right quality for the applications it's being used for. Formaldehyde, a colorless, flammable, pungent-smelling chemical widely used in manufacturing process. Phenol, a toxic colorless/white crystalline solid with distinct sweet and tarry odor, has the molecular formula of C6H5OH. Forming phenolic resin. Major production routes. Phenolic resins are mostly produced through two major routes, Novolic and Rysol synthesis. Novolic resins are produced using an acid catalyst with hexylphenol. These resins are highly used inside of Europe and Japan for their electronics and high-spec applications, while Rysol resins are formed using a base catalyst and hexyl formaldehyde. These resins are mainly used inside of China and India for lower cost applications. There is also alternatives such as bio-green phenol, however these commercial adaptations is still very limited. This is an image inside of a real-life industrial resin production factory, in which they have machines to do the weighing and mixing, polymerization, monitoring material, and cooling. Forming phenolic resin, equipment and technology used. Phenolic resin uses specialized reactor systems, in which typical systems use stirred tank reactors for batch processes or tubular reactors for continuous operations. These reactions used have temperature and pH control to manage exothermic reactions and ensure polymer functions. For purification columns, vessels, and filtration systems, and vacuum distillation care used to remove residual reactants and byproducts. They also use energy recovery systems such as heat exchangers to help give optimized fuel usage. As technology advances, microwave-assisted synthesis and solvent-free processes are being made to also improve fuel usage as well as reducing emissions. This is mainly being implemented inside of Europe and North America to ensure sustainability when manufacturing phenolic resins. This image to the left shows an industrial stirred tank reactor They are used to thoroughly mix reactants as well as containing a stable environment for the chemicals to react in. Finishing phenolic resin. The first step in finishing phenolic resin is curing. It is also known as cross-linking. In this process, the resin must be cured at high temperatures of 150 to 180 degrees Celsius while under pressure in order to transform the material into a rigid thermoset structure. Next, high-speed CNC routers or carbon fiber tools are then used for cutting, milling, or drilling the material while it is still brittle. Surface sanding is then used next, starting with 80 to 100 grit sandpaper to remove any machine marks or imperfections, then 120, 220, and 420 grit to achieve a smooth finish. To achieve a higher gloss appearance, polishing and buffing is needed. They use specialized composite polishing compounds and buffering wheels in order to achieve this. Lastly, if needed, protective coatings are added to ensure and improve UV resistance or aesthetic appearance. This image shows the carbon tip used for drilling and cutting, while the bottom image shows the high grit sandpaper used to finish. Final product of phenolic resin. One of the main uses of phenolic resin is for the resins used inside of circuit breakers. Phenolic materials such as NEMA grades and CE offer superior dimensional stability and structural support for circuit breaker arms, frames, as well as panel boards. Oftentimes, phenolic resins are also designed to be high arc resistant. This makes them ideal for arc chutes and barriers used in circuit breakers. Phenolic resin is used both as molded case circuit breakers and as reinforced laminates, paper or canvas based, for insulating purposes. Overall, phenolic resin is primarily selected for reliability and electrical insulation, as well as being low cost compared to other engineering plastics. This is very important in order to protect facilities from overloads and short circuits. The only issue or downside using phenolic resin is the brittleness under extreme mechanical stress, as well as delamination if heated excessively. These are the resources and sites I used, and I used no AI to help me with this project.